Let us discuss one most important concept, that's your number of reflexive relations in a given set. Suppose A is a set contains n number of elements, and what's the number of reflexive relations in the set A? First of all, the Cartesian product A cross A contains how many elements? The number of elements in A cross A known to you, that is your n square. N into n, that is your n square. And n square number of ordered pairs have been displayed in this table. 1, 2 up to n, 1, 2 up to n, to 1, 1, 1, 2, 1, 3, 1, n. That way n1, n2, n3 up to nn. So in this table, all the ordered pairs or all the elements of A cross A are present in this table. Next, reflexive definition known to us. To be reflexive, it is defined in the set A. So all the identical ordered pair 1, 1, 2, 2, 3, 3 and so on nn. All this ordered pair must be present in the relation. Then only it will be reflexive. In this table, all this 1, 1, 2, 2, 3, 3 and so on up to nn, all these entries are present along the principal diagonal. That's why this is the reflexive relations. That means if you consider A cross A, this relation, it's a reflexive relation. Now, what's the total number of reflexive relation? Now, in some other way, you can think over it. Along the principal diagonal, total number of identical pair, how many? 1, 1, 2, 2, 3, 3, n. So, there are n number of identical ordered pair present here. That means number of ordered pairs along, simply rewrite diagonal, along diagonal equal to n. So along the diagonal there are n number of ordered pair present. Total number of ordered pair here n square. So non-diagonal number of non-diagonal ordered pair. Non-diagonal ordered pair. How many? That's equal to total n square and diagonal ordered pair minus n. So non-diagonal ordered pair how many? N square minus n. Now let us think in some other way. If I remove 1, 2, then this is reflexive or not? Definitely it's a reflexive relation. And if I keep it here, then also it is reflexive relation. If you delete 1, 3 from the table, then also it is reflexive relation. Because the necessary condition to be reflexive, only these principal diagonal ordered pairs, which are present here. But if you delete any one of this, then it will be not reflexive. And similar way, if you delete any one of the non-diagonal entry, then it will be reflexive. So each and every entry having two choices. You may delete it or you may keep it there. That means each and every entry having two choices. Total non-diagonal how many? N square minus n. It means if I write here, each entry having two ways, into two ways, third into two ways, and that way into two ways, there are n square minus n times it will come. Then by fundamental principle of counting, total number of relations will be what? 2 to the power n square minus n. This is the formula, total number of reflexive relations. This is the formula to find out total number of reflexive relations. Now, you can directly use this formula whenever any question, suppose A given A, B, C, and it is asked first the number of total number of reflexive relations can be defined in this set. Then n is what? N is 3 here, and then use this formula 2 to the power n means 3 is squared minus n, that is your 3. That's equal to 2 to the power 3 square is your what? 9. 9 minus 3, that is your 6. And 2 to the power 6 is your 64. That will be 64. So 64 number of reflexive relations will be there in this set, or can be defined in this set. This is the total number of reflexive relations. I hope the concept is clear. You remember this formula. This will give the number of reflexive relations in any set. What is n? N is the number of elements in the set, distinct number of elements in the set. Thank you.